Here the given question is which is wrong. So the first one, B, C, D, which one of the following is wrong? To analyze these answers, so we need to first draw the rigid body, then we can discuss something details in the rigid body. So look at the first option as well as the second option, third option, fourth option. We want to completely analyze the rigid body. That is the thing we are going to do it now.
To analyze this problem, first we need to draw the rigid body diagram. So if you are drawing the rigid body, just you can take any shape. So this is a rigid body. So the atoms are fixed. The distance between any two atoms, if you are taking, that will be remains fixed. That means it won't change. That we can call it a rigid body. The first option it is given, the distance between any two points of a rigid body remains fixed. The first option, if you are writing, yes, obviously. Suppose if you are taking this is a point 1, this is a point 2. The distance between the point 1 and point 2, it is remain fixed. Yeah, that is obviously true. It won't change because it's a rigid body. The rigid body is characterized by the atom interior. The distance between any two atoms, it won't change, so you can call this body is a rigid body. The first option is it's a true. The second option, B, it is given the relative velocity of any point at the position ith particle is expressed in terms of angular velocity omega. Suppose if you are taking this is the ith particle, we can use a different ink. If you are taking this is a ith particle, I am taking my origin, the coordinate system is here. This is represents x-axis, this is y-axis, or you can call this is a z-axis. You can call this as a y-axis. I am taking the point at a distance or the ith particle I here. Suppose if I am rotating this rigid body about this y-axis, or you can rotate about x, or you can rotate about z. If I am rotating about y-axis, suppose consider this y-axis, so that means the point, what it will do, it will also get rotated. It will just move slightly here from here to here. So it will move the angular displacement. If you are rotating about y-axis, that theta, that is the angular displacement of the point ith particle, or you can call the particle at a position ith position, because here trillions atom inside the rigid body. So we are taking the our interest is on the one particle. Now the angular displacement, if you are calculating, you can do that angular displacement ds of the ith particle, that you can call, because it's a small displacement, so you can call it a d theta. Instead of theta, you can call this theta into d theta. The angular displacement ds, this is a ds, this is the angular displacement of the ith particle, that will be equal to the r times the radius distance time the angular displacement d theta. Or another way you can represent, yeah, this is it's a fine. This is from the that arc of the circle can be represented as radius time the angle. That is a formula we are using here. We know the particle I is moving. If you are rotating about y-axis, particle is I moving with the linear velocity to the tangent direction. If you are drawing the tangent, it will move the velocity, that tangent velocity or linear velocity of the ith particle, that would be equal to the ds by dt. This is we know. So if you are substituting the ds here, then linear velocity is equal to r times d theta, that is a ds divided by dt. This would be equal to, if you are taking the r outside, d theta by dt, the angle changes with respect to time, that is called the angular velocity. So you can call that would be equal to omega. Suppose if you are writing this omega equal to d theta by dt, if you are writing in terms of vector quantity, v vector equal to r vector cross omega vector. Here in this it's given omega cross or anyway it's a direction of rotation, it doesn't matter, or cross omega we are read. This is also true. The relative velocity of any point at a position ith particle is expressed in terms of the angular velocity omega. So this that angular velocity is omega. The relation between the linear angular velocity equal to r times omega. The position vector of any point relative to the origin of the body set of axis is constant in magnitude. That is also true. The position of the position vector of any point, suppose if you are taking this point, I am taking this is the origin of the rigid body, the center of the axis, 3 axis. So any point, it is fixed, the it is fixed position, so the relative to the origin is constant, the position vector is constant, it never changes. So the option C also right. So position vector is constant. Even if you are rotating y or x or z, still the position vector is remain change, because coordinates also is rotating with the rigid body. So position vector won't change. Even x and z, y, it will change the direction, but still with respect to the origin, the point I is remains fixed, or any other point if you are taking, that position vector remain fixed with respect to the origin. The last point, the position vector changes in the direction only when the body is in motion or rotation. Definitely it won't change. So whenever the body is in motion or rotation, it doesn't matter, because the coordinate axis associated with the rigid body also in motion. Suppose after rotation, the same rigid body, what would happen? Suppose if the rigid body is now it's became like that, what would happen? My coordinates also got rotated. Like my z axis should be here, my x axis should be here, my y axis should be here. That means I have rotated some such that the coordinate axis also get rotated. If you are choosing that any point, still the point ith position is still fixed. So it doesn't change the direction, because the coordinate axis also got rotated. Then the option D is wrong answer. The position vector changes in the direction only when the body. The position vector never change. So the position vector changes. So this is the wrong answer.
So from the above analysis, the distance between the any 2 points of the rigid body remains fixed. This is right. Then the relative velocity of any point at a position of ith particle is expected in terms of the angular velocity. This is also right. The position vector of any point related to the origin of the body's set of axes is constant in magnitude. This is also right. The position vector changes in the direction only when the body is in motion or rotation. This is the wrong one. The option D is so appropriate option for the given question.